Hey, welcome everyone to part 2 of the prequel for the F1 Gearbox. The one area I didn't get to address in part 1 that I've received a lot of questions around is what would it take to make this design actually usable for a real car? I think it's actually a cool thought challenge that highlights even more how amazing the engineers that design these gearboxes are. And you have to ignore certain things like the fact that these tolerances and things are set up for FDM printing. But overall, I think it's still a cool process to walk through here. So I think a good place to start with this video is an overview of the overall gearbox, which I haven't really covered in the previous videos. I mean, obviously there's a case that fits all these gears, but this is just really a portion of the F1 gearbox. It's usually referred to as the cassette. The gear ratios of the cassette are actually very close together. Some of them are only varied by 1 or 2 teeth. So this really necessitates a significant widening of the ratios. So in the real gearbox, at the back of the output shaft, right here, there is a bevel gear, and then it actually goes into a set of change gears, which come out the back, and they're actually this direction. And that goes up to the differential, which is actually way up here above the rest of the gear stack. So obviously these gearboxes are, designed for mid-engine open wheel cars. The real reason that this layout exists is because they want as low center of gravity as possible to have the gears, which are going to be the heaviest part of the gearbox, down low, and then they want it to narrow as it gets further back for better aerodynamics. So the clutch assembly of the F1 gearbox is an engineering feat of all its own. The real gearbox uses carbon-carbon clutches, which are just 110 millimeters in diameter. I don't know if that's even possible or how much these cost, but I would imagine a more conventional multi-plate clutch could be custom designed to fit in such a place. I'm not sure how much torque you'd be able to handle, but perhaps something from an Indy car may fit. You also need a hydraulic setup for the clutch, or a way to adapt it to potentially a hydraulic clutch pedal or something like that, so that you can actually actuate the clutch. I'd be interested to know what's possible there. But so I think another aspect that would have to be looked at when you actually try to use this in a real car would be the actual bearings themselves. Of course, F1 gearboxes don't use cheap bearings like these. This model uses 6706 thin section ball bearing, which is really not up to the task of handling very much load or significant RPM. While like a 6707 bearing could be fit into this design and has a lot more desirable characteristics, I'm not sure its load capabilities are enough for an actual, car. But again, I'm not really an engineer, so I wouldn't know exactly. But most likely all these bearings would need to be upgraded with roller bearings, which is what the real F1 gearbox uses. And these hubs that the slider go on would actually be extended. They're actually made into one piece, and so it would go out to here, and then the ball bearings, or not the ball bearings, the roller bearings would have essentially a race on which to spin. And then for the ends of the actual input and output shafts, I think you would need some sort of angular contact bearing or tapered bearings. I'm not sure exactly what the real F1 gearbox uses, but there would be always the potential for some axial loads. And I'm not sure if those loads are small enough that you don't require some sort of specialized bearing, but I think I would definitely upgrade the end bearings, because I'm just again using those little 6706 bearings on the ends, which definitely aren't up to taking a significant amount of load. And while we've got this out, actually, I think another area that you would have to upgrade would be the actual shafts themselves. Of course, with different bearings, you could go to a larger diameter shaft, which would take a significantly higher load. The other important thing is that, again, I copied, I think, a one-off design that Honda did for their gearboxes with 5 splines. It's going to be much stronger to have a multi-spline, which I believe the real gearbox that this is based off of has, similar to what I have here on the lay shaft. And another important thing probably to add to these shafts would be some sort of like a machined groove for a circlip, or I'm not sure if you've got angular contact bearings, whether or not it's just a collar that you can have on here. That's essentially all that we have on the model, is just a collar with a couple of set screws that holds all the gears onto the shaft. But but they're not really trying to go anywhere because the loads are so light at this point. I think if you were going to actually use reverse gear, this would be another area that you'd have to do a significant amount of engineering on, but I honestly would be very tempted to just throw out the reverse gear because it's very specific to Formula One. It's too light duty to do any meaningful amount of reverse, and it just complicates the design even further. So again, I would probably just throw it out. Race cars don't need reverse, right? Now I think the actual actuators to move the shift barrels is actually an interesting potential area that could be changed and actually cost less. I'm only using $5 stepper motors right here, and I think that realistically you're going to need much more powerful motors in a real gearbox. I think you may be able to do something electronic with a high-speed servo of some sort. Again, it would have to move very quickly, and it would have to be extremely precise to be able to work. I don't think pneumatics are really a good application for this, just mainly because I don't think you're going to get the precision and the control needed to be able to seamlessly shift. Probably your best option if you have it as a possibility would be hydraulics. This is what the real gearbox uses because you can just get so much power in such a compact space, as well as having the ability to have something that's extremely reactive and fast moving while being accurate at the same time. This is really what you need to be able to accomplish seamless shifting, because you're going to have to shift move these shift barrels, between shifts in like less than a millisecond per shift barrel. So that's moving pretty darn quick, and you have to be able to stop at the same time. Obviously with the RPMs that this gearbox sees, lubrication and cooling are extremely important. The F1 gearbox, I believe, has an integrated miniature oil pump in here, but I'm not 100% sure. I can't find any pictures of this area. It's actually an interesting question to find out how the lubrication system works for this gearbox. But I think it'd probably be easiest just to use an external pump. That way you can just feed the oil back in and just have it driven off of the engine or the gearbox somewhere. I think it's just going to be a lot easier setup. That way you can have an external oil cooler and all of that. I don't know if there's some sort of pressure feed that actually would feed the like a rail that sprayed oil down on these gears, or if it's just like a typical gearbox where it just uses the motion of the gears themselves to throw the oil around the entire gearbox. It'd be an interesting thing to find out if anyone knows more about how the lubrication actually works in these gearboxes. Now, of course, the model just uses a cheap like $7 microcontroller, and again, I mentioned like $5 stepper motors. The controller is very rudimentary. It doesn't have a lot of the safety features and testing routines that the real gearbox would have. This is mainly due to the fact that, really only have, 2 RPM sensors, and then we have 2 sensors on the shift barrels that sense the position. I would imagine that the real gearbox is going to have temperature sensors. It's going to probably have multiple redundant sensors for a lot of these functions. Again, I don't think the sensors and the actual electronics hardware have to be that expensive, but you're definitely going to need most likely a network of microcontrollers that can process a lot of data, real time, to be able to bring it all together so that you can come up with a comprehensive controller for the gearbox that's actually going to reliably shift the gears. And you also have to take into account the rest of the vehicle's dynamics when you start building a real controller for this gearbox. For example, I already know that there's multiple shift modes that these things implement. So for example, part throttle acceleration does not use seamless shifting in the real F1 gearbox. It requires more than 85% throttle to go into seamless shifting. And then there's all sorts of other conditions, regarding the amount of lateral load on the car, even settings that are specifically programmed per racetrack, so that a harsh downshift won't occur in the middle of a corner, that shift will be smoother. So there's all sorts of things to take into account. I know for a fact that even warming these gearboxes up requires a controller to manage a significant amount of data, and that each gearbox has to learn and adapt individually to the temperatures and the different viscosities of the oil, the load, and even the age. Again, like I said, from materials cost, I think this is probably one of the cheapest areas of the gearbox. Of course, I'm if you wanted to go with, motorsport grade electronics like they used in the real gearbox, is going to be massively more expensive. But from a time perspective, I would expect this probably to be the largest portion of really what it takes to build this gearbox. I've already spent, far more time tuning the electronics and figuring out how to just do a basic rudimentary microcontroller than I did in the actual, physical design of the entire gearbox. Now, I think the next two items are what really separates this gearbox from the gearbox that you'd find in your typical car. And really, it's the materials and the seamless shifting capabilities. I can't say enough about the level of obsessiveness taken from a material science perspective in an F1 gearbox. There's articles all over the internet talking about, various grad papers of, people dedicating their entire thesis just to coming up with different materials for these gearboxes. Everything in the F1 gearbox is top spec materials with very consistent quality and specifications. Most of it coming from the aerospace industry. This allows F1 engineers to be able to push the design envelope to the limit. The bearings are from airplanes and have cages made of titanium. The transmission cases aren't made of metal, but carbon Kevlar composites. As I've mentioned, and I can't really, illustrate this enough, these gears are only 12 millimeters wide. That's extremely narrow. And they're made of steel and rated to handle 250 foot-pound of continuous torque with peaks to over 400 foot-pounds. Obviously, these parts can't be made from cheap castings or even milled from a billet without significantly lowering the torque capacity of the gearbox. But needless to say, I imagine these gears are made from aerospace or custom alloys spec'd by the engineers. The gears would undoubtedly go through a rigorous forming, machining, and treatment process. And, the gears are undoubtedly die forged in something like the heart of an active volcano. Then they'll be machined, post-treated, and coated in some sort of unobtainium coating, low friction coating. Now, I think these gears might be able to handle more torque, but seamless shifting causes massive shock loads to go through the entire gearbox, particularly with high aero loads. When they first started testing these gearboxes, seamless shifts would literally shatter the gears, the CV joints, the axles, even the uprights on the rear of the chassis. So that's a huge shock load. I don't know, much about the materials and the manufacturing processes, but I would hazard a guess that to make just a few sets of these gears and the necessary tooling would not be a cheap endeavor. So, if you wanted to make it cheaper, I think you'd probably have to make the parts larger. You're talking, probably 20 to 30 millimeter wide gears, which probably adds, another 5 to 15 centimeters to the cassette. The dog teeth are going to need to be larger, which may affect how the shifting works as well. I'm not sure. Needless to say, I think a fair amount of engineering would be needed to reconfigure this design to be more cost effectively manufactured, but I think that is definitely doable. I think the single most expensive part of the seamless shifting gearbox development process is the spares needed. I've already found this out just trying to build a model, but the unfortunate issue with these gearboxes is that the slightest mistiming in the shifts will actually lock it up and destroy it. I found some articles on, I think, F1technical.net where they talk about it took F1 engineers 2 to 3 years of testing to perfect these gearboxes before they were actually usable in an F1 car. And I'd hazard a guess that was several $1 million worth of broken gearboxes over those years. Realistically, if the rules allow, just get a double clutch gearbox. They're heavier and need more room, but they can be just as fast as an F1 gearbox. If you're not chasing hundredths of a second per lap, then just buy a really nice gearbox from X-Track, Samsonis, or Hewlin with a single shift barrel, because it's less complicated, will shift extremely fast, and you don't run the risk of locking up your transmission when something goes wrong. I've also had a few people ask, how can you actually lock up a gearbox? And it may not be intuitive to everyone, who's been dealing with street gearboxes. But of course, the dual shift barrels allow you to independently control the odd and even gears, which allows for the potential of two gears to be engaged at the same time with different ratios. So like as you can see here, if I engage second gear and first gear, it doesn't feel too bad. But then as you start to rotate it about half a turn, and then boom, the entire gearbox is locked up. And at this point, everything breaks. All the dogs get sheared off. And essentially, if it's a real gearbox, all the parts and pieces and metal are going to go through everything, and the gearbox is destroyed. So that's why it's very expensive to develop one of these gearboxes. Now, I know all this may sound very negative, but I think it's actually kind of cool to see the lengths that the F1 engineers had to go to create one of these gearboxes to meet a very specific set of rules and requirements. I'd still love to see one of these gearboxes built and used in, say, an open wheel race car with a little bit lower power. So if anyone's going to try this, let me know, and I'll definitely be a subscriber to your YouTube channel. I'm also curious just how strong a gearbox made with FDM printing could be. I know they'd never be used in a real car, but I'm tempted to kind of build a test rig and see how strong the current parts are, as well as kind of try some different materials and designs and see what might be able to be accomplished. Let me know in the comments if that's something you guys would all find interesting. As you might have seen, there's some additional parts been added to the gearbox. I've realized it's impossible to test the vehicle simulation when the gearbox occasionally locks up and breaks. So I need to upgrade a few areas of the gearbox and sacrifice some speed for now for additional reliability when shifting. I've gotten some parts from China, such as encoders and some other things. So I'm hoping for the next episode to be able to have the gearbox kind of rewired and at a point where I can start actually hopefully testing some of the vehicle simulation side of things and having a reliable shift. Otherwise, I'll be, kicking off my next project. So thanks everyone for watching. If you enjoyed this episode, please hit the like button. And if you want to see more content like this, please consider subscribing. Thanks.